right. Hello, everyone. Welcome to another Carolinas Snowflake Meetup Group event. Tonight, we'll be talking about customer segmentation using Python and Snowflake. We have a few meetup rules to go over real quick. Just that everybody's respectful and stays on mute unless they have something important to say, and use the chat to ask any questions so that everybody can read them, and try to keep everything on topic. And you can keep your video on or off, whatever you're comfortable with, and always invite a friend. And of course, ping us on Twitter. Tonight, we're going to be going over an introduction to customer segmentation, talking about a few use cases, having a dataset walkthrough, and a little bit of data modeling with Anupov. And we'll talk about our beta program briefly. And then we'll have an open discussion for any questions and talk about our upcoming events. All of our previous meetups are on YouTube, and that you can find in the discussions in our meetup group. Christian, you want to go over a quick?
Yeah. So we always do this quick refresher on Snowflake, just because we know we have some people who are new to Snowflake and some people who are probably SnowPro core certified at this point. But really high level, what is Snowflake, right? So Snowflake is a data cloud. It is a SaaS-based offering that's 100% cloud centric. It's a modern data stack repository that handles data ingestion, good data governance. They have a unique take on access to data. And then with their compute and disk separation, they basically allow almost infinite scale on data operations. So really unique stance they took to solve some major problems in the market with data, as you guys probably know. It's a great way to take any of these data points, events, transactions, so forth, take them all the way through that data pipeline into something that's actually consumable by different types of data users and data workers. So we like Snowflake. We think it solves very, very real problems in the real world. And we've been using it for a long time. And that's one reason we love having these meetups, so we can talk about Snowflake and share some of our thoughts, and also hear from everybody else as well in their experiences. Mike, you're up.
Mike's gonna give our introduction to customer segmentation.
Cool. So just a quick story here. There's a dad went into a Target up in Minneapolis and demanded to talk to the store manager. He was absolutely furious, and store manager came over and said, "Hey, how can I help you?" And clearly the dad was a bit disheveled and upset. And so the manager knew, hey, I've got to approach this with kid gloves and have empathy. And the dad started shaking a bunch of coupons in front of the store manager's face and said, "How dare you send my underage daughter pregnancy related coupons?" And the manager fiercely apologized, said, "Oh my goodness, sir, that is not the intent. I don't know what happened. I'll look into it." And sure enough, a week later, the store manager called the dad back and said, "Sir, I apologize. We did send those. It was the company was using data to try to better understand what was happening." And the dad fired back and said, "Well, actually, I owe you an apology. There's some things been going on in my household that I wasn't aware of, and my daughter is due in later this summer." And so what that really showcased is definitely one way to segment your customers. And really, it came down to a data scientist at Target who was doing market basket analysis of what were people buying and what were those products in the basket. What did they potentially tell about the future or future purchases? And could Target use that to help send coupons and engage with that customer, especially when you look at expecting families or individuals, that those early days when you find out that you're pregnant, those are very, very key moments from a buying perspective of what items and things will that mother be, purchasing, whether it's for the baby, for herself, from vitamins and other personal care items. And so of the traditional 25 items within the basket that were identified as, there's some sort of a correlation that we can make. This data scientist applied a score to every one of those items in the basket. And that score, when you combine it together with other items in the basket, was used as a predictor of, here's the types of coupons that we should be sending our customers so that they purchase additional things from us as Target. So that sounds awesome on paper. However, the execution, well, that needed some refinement, as the dad and manager story. So now Target is actually taking a little bit different approach, that common items that are purchased in that 25 or to those 25 items, a lot of times Target will stack and position other things on end caps of those aisles that might be unrelated, some different candies and some other foods. And also, when the coupons are now sent out, Target actually will not only send out, in this case, from an expectant perspective, but it also will add in other things that are not related, things that are furniture, clothing for adults, and just other non-related things to pregnancy, so that for some families, they might not want to get the word out that, hey, we're expecting, and others just don't want to be thrown in their face of, hey, we know you're expecting, here's some coupons. Hey, we know you're expecting, here's some more coupons. Like, oh my goodness. So now, if you are lucky enough to get some of those Target coupon books, there's other non-related things that you'll see in there. And it really stems back to, we segmented our customer, we identified through market basket analysis the predictive behaviors of future purchases, and using that data, they're able to now market to those individual customers. So while it is a little bit on the surface, a bit lighthearted story, it's really what we're talking about here is how we're using data to segment our customers, or your customers, at the end of the day. So some use cases, lots of different things. We talked about the market basket analysis here. Naturally, from a loyalty perspective, very straightforward of, all right, if you consistently buy, A, B, and C, or you think of airlines, they're really good about the miles game of, hey, you get a credit card, or you buy, X dollars from restaurants within the next 3 months, we'll triple those points. And so really that gamification by using and targeting from a customer segmentation perspective. Naturally, there's other efficiencies and segmentation that you can do relative to commercial real estate, for example. All right, you're not just creating buildings or leasing out space, you're actually targeting, all right, if you're life sciences, there's particular things that the life sciences industry needs. If you're manufacturing, there's particular things that they need and want to look for. And that even from transportation perspective, when you look at different, whether it's route optimization, but more importantly, all right, that fleet maintenance, and what are those different parts and services that can be offered to those either truckers or those transportation organizations. And likewise, we talk about data warehouse as a service, that's where all your data is coming from, and you're trying to make sense of this, doing the segmentation, and naturally turning that into sales and marketing activities. So we'll go to the next slide. So today we want to accomplish a number of different things. We talked about the story relative to Target, about understanding your consumer spending, buying behaviors, and also it's one thing once you understand them, what are you trying to do, and how much are you trying to increase the, your bottom line in your own organization, or perhaps you're just trying to increase the total spend with the customer, and you're not as worried about what is the bottom line impact, because it's really all about that, customer and brand attraction. And then you're using that to do prediction, classification, and continually refine these models. Next slide.
All right, so now I think we want to look through just to give a little bit of background on the data set that we used and how we actually were able to perform some of those analytics. But just briefly about the data set, we were kind of in search of some data that gave us the ability, like Mike was talking about, to look into a lot of different facets into how we could segment based on kind of a customer base that we were looking at. And one of the struggles that we found was that a lot of the data sets are, companies do not want to give out sales records just all willy-nilly. So what we ran into a lot was a lot of randomly generated data sets, and this was kind of where we ended up just taking one data set that we liked, probably very randomized data, not very clean, or a little maybe too clean. But anyway, we found a data set on Kaggle that had about 1,000 records of supermarket sales that were grouped by like an invoice level based on a customer's visit to that supermarket. So it had a couple fields for unit price and quantity of items purchased, and then the actual grouping of products as they pertain to, so like health and beauty versus food versus other cosmetic items. And then we also, there was another field about customer type. So whether this person was a member or had a membership to that specific supermarket, or whether they were just a person walking off the street. So that's a little bit about the data set. And then our goal was to get that into Snowflake so that we could end up doing a lot of performative analytics on that and moving into the whole clustering of the data as well. So can you go to the next slide, Heather? Thank you. So and we just wanted to give a little background on actually loading data into Snowflake. So 3 primary methods that Snowflake they give out on their level of documentation online. They give out the option to use the Snowflake UI just to load data in there, which it's very no code centric, where you are able to just specify the data set you're hoping to integrate using a specified file format, and it will perform the put and copy commands behind the scenes. Put being the process where data is loaded into a stage, internal or external. Internal being kind of like a local machine, whereas external is going to be something more like S3. And then copy being actually taking that data from the stage and putting it into a target data set. So this is going to be a solution for small files, because Snowflake does limit the data size of incoming data into those tables. So I think they say, yeah, we've got 50 megabytes specified there. So this is the solution we use because we were only using a data set with a size of 1,000 records. But if you're looking for more of a bulk solution, this is where the SnowSQL client comes into play. It's a CLI solution to where you have a lot more freedom to be able to specify any sort of formats in your put and copy commands, and loading into specific stages. But a lot more freedom over the configurations that you make, and you get a lot more in the way of data availability to be put into Snowflake. And then there's Snowpipe, which is the option you can use to load continuous data. So this is going to be a great solution if you are using AWS S3, where you've got some sort of automated process that's continually dropping files into an S3 bucket. What you end up doing is being able to specify that S3 bucket as your external stage, And what Snowflake will do is it will, via Snowpipe, it will pick up these new files and then kind of stream them into your target data set. And it'll appear pretty shortly after you after that data becomes available inside of the stage. So I think now we're going to move on to the actual data modeling part, and Anupam took a lot of this.
Thank you, Drew. I'll take it forward from here. Heather, I think you'll have to stop sharing before I can start sharing. Thank you. So I'll just share my screen. Can you just let me know if you guys can see my Jupyter notebook?
Yeah,
Okay.
we see it.
Okay, so what we've done is we've connected a Python Jupyter notebook and pulled data from Snowflake, and we've basically imported libraries in Python, which is called as the Snowflake Connector library. Before I jump to the part where we talk about Python and all the libraries being used here and the machine learning aspect of the entire segmentation problem. Just continuing and sharing some more information on what Drew just spoke about, the data set. So it's increasingly difficult to find data which is around customer and customer information, because companies usually like to keep it private, usually like keep it for their own analysis and so on. So we happen to pick up a very good mocked data from Kaggle. For people that new around the space of Kaggle, it's a great place to kind of find good data sets, data sources, and kind of also play around with a lot of machine learning computation and so on. So we've given the sources in the notebook, and this data source basically has around 17 features, 17 columns. And if you look at that, you have information such as the invoice ID, which talks about the branch of the supermarkets, the location of the supermarkets, what's the type of customer, was it a member customer, normal customer, your gender of the customer, what's the price of the item that they bought, the quantity, the tax, and so on, and the cost of goods, and what's the gross income, and so on. So we'll talk more about this data set as I go ahead and kind of talk about various features. Moving on to the libraries in Python, we've called the Snowflake connector to connect with Snowflake, and we've used all the pandas, NumPy, and so on to perform a machine learning processing. And then we've used the standard scikit-learn library to perform clustering, and you see everything being pulled from scikit-learn and so on. So this is the part where we connect with Snowflake to fetch data. And as you can see, you can call the connected.connect method and then pass in your username, password, account name, and so on. Within Snowflake, you've got to use a role in Snowflake that will be used to kind of execute your statements, the name of your database and the warehouse. And then as you see down here, it lets you execute SQL commands just like you would do in any Snowflake or any SQL IDE. And then what you do is you kind of call the fetch pandas all and fetch the information or the output from this query as part of this data frame. So for people new in the world of pandas, it's like a table which you call as data frame, and all the processing is done within data frames in pandas. So we execute the fetch pandas all, get the data in something called as this data frame sales master. And then we kind of go ahead to kind of process the data, see what the data looks like. So you have a method called .shape, again from pandas data frame. It tells you that we've loaded 1,000 records and 17 columns. You do a quick head, you can see, so when you do head, it gives you by default the top 5 rows in your data frame. If you put the number here to the function, you can actually call more rows. So if you pass head 25, you can see top 25 rows in your data frame and so on. So your invoice ID looks like a complex number with alphanumeric format to it. And then you've got your branch details, your city of the supermarket, type of customer, the gender of the customer, what's the product line of the product we're talking about, what's the price, the quantity, the tax, total cost, date of purchase, time of purchase, payment method, cost of goods sold, and the gross income of the customer that's currently purchasing this particular product, and the rating that's given by the customer here. And then for the analysis, we see that we have data which ranges currently from 1st of January to 30th of March 2019. So it's 3 months of data. And then just to kind of understand what's the data type of the column being called, if you just do a .info method, you see that you have a float, integer, and an object is like a variant which you can hold string and mix data type values in pandas in Python. Checking for any duplicate entries. So just doing a duplicate.sum, it indicates we have no duplicate entries, so we're good on that. And then just looking at the various values that we have, unique value in each column. So calling a .unique method on your column name kind of tells you what are the unique values that you have. So we have 3 centers with the name ABC. Again, it's a mock data, so ABC. And then for city, we have 3 cities, Yangon, Naypyidaw, and Mandalay, which I believe are cities based out of Burma. And then similarly for the male and female, the member and the normal for the customer type. Then what we've done is, as I showed previously, that this invoice ID in our data set is a very complex alphanumeric character here. We've used something called as a label encoder, which essentially converts this complex invoice ID into a list of numbers. And that's kind of done to make it easy for us to process when we do clustering in machine learning. And that's what we've done. We've converted those complex numbers to simple numbers that's easy to kind of process when we pass this data to a machine learning model. So we've used label encoder, but there are more encoding techniques that you can use. You have one-hot encoding, categorical encoder, and so on. And then in addition to the data analysis that you can do in SQL, in Python, it kind of helps to look at, you can go deeper in terms of the plots you make and the various columns you look at. So for each column, we've done a quick plot analysis here. And then as you see that, again, being a mocked up data, you see that the distribution of data for each column is kind of similar. So you have a perfect break of data across branches, similar data breakdown across cities, customer type 50% across male and female, 50% across member, non-member, and then approximately 17% of data breakdown across each of these columns that the product categories that you have. And then we've drawn a box plot to see if there's any difference in terms of the rating. So on the y-axis, you have the rating that's given by the customer for each branch. So your branch A and branch C have similar ratings, but your branch B is for some reason has been given a lesser rating compared to A and C. So that's good to know. Similarly, if we plotted the rating given by customer across each product line, and it's pretty much similar, no much change to it. And we've also tried to kind of break down the gross income. So basically we've seen where do high spending customers spend the most. And that's pretty much also not varying a lot across the product lines. So you have high paying customers also spending across all of these branches. Yeah, this is an important one because this kind of indicates that as part of the feature engineering, when you say feature engineering, it always helps to kind of control the number of columns of features that you pass to a machine learning model to ensure that you don't have any features which are kind of duplicated or which are kind of giving you the same information again and again. So you have something called as a correlation matrix, which kind of indicates what's the correlation between any two columns or any two features at a given time. And the value of correlation will range between +1 to -1. +1 indicates that it's the strongest correlation, and -1 is that they're negatively correlated in the opposite direction. So anything which is red in color or amber in color indicates strong correlation. And what is good to know is, interesting to know is that gross income, so customers with high income are positively correlated with unit price. So which might indicate that customers which have high gross income are probably willing to buy items which have higher unit price. And similarly, customers with higher gross income have strong correlation with quantity, so they're more likely to buy higher number of items. But this is again, something we've got to be careful is that we should not assume correlation to be cause for causation. So it's always good to keep that at the back of your mind, that these are just indicators and not final answers to each of the questions that we ask. And I think this is pretty much logical that tax, total, and the cost of goods sold have to be correlated with the unit price and quantity, because if you sell more items, you are likely to pay more cost of goods sold and higher tax and total amount and so on. I think I just take a quick break here for a few seconds. If there are any questions before I go ahead. Okay. This one, and then I think one good thing we also wanted to see was, is there any difference on the difference in the number of items that are being sold on a daily basis? For example, you would expect that probably during the start of the month, you might expect people to buy more, and then probably end of the month, people to buy less. But we could not see any specific trend, at least in the data that we've used. It pretty much seemed to be following a random pattern here. So even the day-wise breakup did not give us a lot of information. Yeah, and just in continuation to the previous analysis, if you plot the unit price on the y-axis with the gross income, it does indicate that customers with higher gross income are kind of more populated towards higher unit price. And then if you look at the lower quadrant, customers with lesser gross income are probably more densely connected towards the lower end of the plot. So which is again linked with higher income customers are more likely to buy quantity products with higher unit price. Just another way to look at it. And then this is just to kind of show that if people are interested to see what's the mean, what's the max standard deviation, which is something called as your inferential statistics, your descriptive statistics, to understand what the data looks like. So you can see, for example, the average rating of an experience is around 7. Then the average unit price of data is around $56, and so on. You could do an average to see what the average mean, mode, and so on is. So that was more from an EDA standpoint, data exploration standpoint, to see what our data tells us. And now what we've done is we've kind of gone ahead to see that if we just take this data set and then if we kind of apply a machine learning technique, which is called as a clustering, and clustering is unsupervised learning. When I say unsupervised learning, that we've not told an algorithm or we've not created any train and test scenarios, and we've just given the data as it is to the machine learning algorithm to find any patterns, and using those patterns, it creates categories for us, which can be segmented in this particular scenario. And this is just tip of the iceberg. There are many ways of doing customer segmentation. We've gone with one commonly used approach, which is called as k-means clustering. What basically it does is that K stands for the number of clusters that you want your algorithm to create. And then based on those clusters, you can kind of correlate and see that what does my data kind of tell me. So for example, in this scenario, we've tried to create clusters to see if our algorithm can kind of divide the data set that we have into something called as low-paying customers, high-paying customers, and so on. So that's the kind of analysis, that's the segmentation that we've tried to do as part of this particular meetup. Before I go into showing the analysis details, just a quick discussion on what k-means clustering is. So as I said, it's unsupervised learning algorithm. There's been no training done on the algorithm as such. And what we'll basically do is we'll talk about how do you run a k-means algorithm, what parameters are used to kind of customize the algorithm. And then we'll talk about something called as an inertia curve. That is a good way to come up with the value of k, that what is the most optimized value of k you can use given your data set. So what by principle, what k-means does is that, and I'll quickly spend some time on the algorithm here, is that once you choose a number of clusters, let's say I want to have 3 clusters for my analysis. As step 2, it starts with choosing random points from your data as centroids. When you say centroids, they can just be taken as center of you can take them as center of your value, as basically pillars of your value. And then what it does is, based on the numbers, so for example, if I have 3 clusters, it takes 3 random values as the center of my clusters. And then it picks up each of the value data point in my data set to find the shortest distance between these random values, and then kind of clusters them together. So it does this in iterations, very similar to Monte Carlo simulations. It runs them in, keeps running them in multiple loops till it finds the best possible set of clusters which are closely linked to each other. So its main 2 properties are that all the data points which are linked in one cluster should have the smallest distance between them and the centroid, and each centroid between themselves, your intercluster distance should be as far as possible. So ideally, you should have minimum intra-cluster distance and maximum inter-cluster distance. That's what the k-means algorithm works to kind of reach at. And it basically stops that when it sees that no more centroids can be found. You've optimized the entire search based on the distances, and your points are starting to remain constant or similar in your cluster. Or if you specified that, hey, my loop should only run for, let's say, 10,000 times, then it kind of exits when the 10,000 iterations have been done as part of the algorithm execution. So as I said, choosing the right number of clusters is very important. So how do you know you pick 3 clusters, 4 clusters, 5 clusters, and so on? So for that, one possible approach is that if you have a business need, if your business might come and say, hey, you know what, just divide the data into 4 clusters and tell us what's possible, then you have the k value given to you. But if not, if you want to find the optimized value, then we have something called as inertia analysis. Inertia is nothing but it's basically the sum of the intra-cluster distances. So you have your centroid here, and then you have basically data points in your clusters here. It tries to find the sum of the intra-cluster distance. So essentially what it does is, if you come to plotting it down, it's called the elbow method, by the way, and it's called elbow because what it does is we've plotted the inertia or the intra-cluster distance for each number of clusters. And then ideally, we want to choose the one which has the lowest inertia for the given value of cluster. And then when you plot this chart, you would often see like an elbow shape here, something like this being created, which indicates that that particular value is a point of deflection where your value is gone down and will start to kind of stabilize after that. So in this particular plot, you see at value 2 and 3. So cluster number 2 and 3 is when your inertia reduces, but going after that, going forward, it's pretty much stabilized. So whether you choose 4 clusters or 6 clusters or 8, it's not going to make a difference. So you might want to choose 2 or 3 or 4 or one of them for analysis to kind of get the optimized answer. And from scikit-learn, we already have something called as k-means. So scikit-learn is a very well-known, very commonly used Python library for machine learning, not just k-means, but most of the other things also covered in scikit-learn. And then we've called the k-means method. So just to plot this graph, we've plotted from 1 to 11 to see what the inertia value looks like. So it internally calculates the inertia for you, given based on the number of clusters you pass. And we use something called as k-means plus plus. K-means plus plus is nothing but it's just k-means where it has a more optimized approach to select the first random points. So instead of choosing random points, there's an algorithm in k-means plus plus where it chooses based on the algorithm that what are the initial points that should be chosen as your starting point for centroids. So we've taken that, and after that, So this is one way to kind of initialize. And I think what happens is that it's easy to analyze the entire thing when you have 2 features or 3 features, when you can plot them on 1 dimension or 2 dimension or 3 dimension. But once you go beyond 3 dimensions to multiple dimensions, for example, you have 17 features here. So it forms 17 different dimensions, which the human mind cannot kind of imagine. So in that particular way, it's good to kind of use this cluster analysis to see that for 17 dimensions, what is the right value of my clusters. So for this particular scenario, it says that anything between 2 and 3 and 4 might be a good idea to use for your k-means clustering. So I've taken 3 as this piece of code. And then I've initialized the k-means method. And then I have passed my value x, from which so when I say fit and predict, based on my features, based on the algorithm, it kind of maps clusters value to all your data points internally and tells you that. So for example, if you have 5 rows, it will do the analysis and say that row number 1 goes to cluster number 1, row number 2 will go to cluster number 2, cluster number 3, and so on. So it just gives you clusters. So for example, if I come down, and just because this data is such a beautiful data where things are perfectly correlated and it's kind of simple that way. So that's why you see a very nice linear plot of clusters being created. But more often than not, you will see clusters, something like one cluster being created here, one cluster being created here, one cluster being created here. But what it's done is, since I've chosen 3, it's told me that you have some set of values which can be taken as one cluster here. And then you have another set of values which can be one cluster here. So I've just called them as class 1, class 2, class 3, but essentially they're cluster 1, cluster 2, cluster 3. And then when you have one set of clusters which are mapped here. Now it's just told me 3 clusters. It's the task of the analyst or the data scientist or data engineer to kind of look at what the clusters output has come and what does it mean for the business. So in this particular scenario, if I look at my plot or my data, I'm trying to plot the total expenditure with my gross income. So looking at that particular plot, what we can kind of analyze is that this particular cluster is kind of talking about those scenarios where your customers with increasing gross income are, or you can say with items which are higher in expenditure, are being bought by customers with increasing gross income or high paying customers. And similarly, so you can kind of tell that these are low paying customers. And then if you look at this particular cluster, these are probably customers who are a little higher than the high paying customers. And then these cluster of groups are the highest paying customers that you have in your data set. And this is again dependent on what your x-axis or your point of analysis is. So yeah, it kind of creates the cluster for you. And then we've listed some more sources that you guys can read on Kaggle. There are much more different pieces of analysis being done by people on the same data set. Good way to kind of look at different approaches and kind of get more ideas on this particular concept. So I think I've covered from a clustering standpoint. If there are any more questions, happy to take it now.
Thanks, Anupam. I can share now if you let me. So as far as next steps go, if you are trying to do any real analysis, you're going to want to find a better data source than we found because it was all, as you can see, pretty flat and not very robust. You can segment on if this was a more robust data set, you could segment based on gender, the product line, the location, their loyalty status, I think was also included in there to find all kinds of great insights. And then you would adjust your marketing strategy accordingly. We are AICG, the developers of the DataLakeHouse platform, and we have a beta program going on right now. Our platform, DataLakeHouse, is capable of ELT. There's no code required, and it uses machine learning and produces analytics, and we also have a data catalog and all kinds of cool features. And if anybody's interested in joining our beta program, we've got a link that I'll put in the chat right now. And we've got all kinds of cool stuff we're offering in exchange for a little bit of feedback on our platform. And the link will take you to our site where you'll just fill out this short little form, and then we'll send you some next steps in your inbox. Oh, I didn't mean to click on it, sorry. It's not wanting to switch the slide on me. Yep, so this is our no bad data mascot, just to show that we don't believe that there is such thing as bad data, only bad processes. And yeah, that's basically the end of this meetup. Does anybody have any questions?
So a great walkthrough, guys. Awesome material there. I don't know. I guess a quick question for you on, if you were to take some of that clustering and try to, identify some of the customers, maybe, if you're looking for top 3 cluster of customers based on buying behavior, there's the modeling step there, but what would you give as, insight to a next step there for maybe a marketing team or something like that? What would you say a good next step would be?
Yeah, in fact, that's a great question, Christian, because what you can do is that once you have the clusters created, right? So in my scenario, for example, we spoke about class 1, 2, and 3. So what you can actually do is you can take the data set, and within data frame itself, you can specify that, hey, just pick up those customers which have been marked, let's say, as part of cluster 1 and 2. So for example, if I say my highest paying customers based on the output I see is cluster number 3. So I just segment and pick up the value where cluster number is 3. And then, so I know that this set of 50 people or 60 people in my data records are the highest paying customer. And then you can use that to further see if you have any other trends within that data set. So for example, if you want to see that within the 60 customers, you see male gender spending more than female or female spending more than male, or what are the product lines they're looking at, what's the average cost, what's the average taxes they've paid, and so on. So you can further mine deeper by creating a subset of your target cluster.
Awesome.
And you in data science, right, you do something called as ensemble, and clusters are usually a part of an ensemble where you take the output of a cluster to kind of put that into some other machine learning algorithm and then get some further data analysis, predictions, and segmentation, and so on.
Awesome. Yeah, I'm sure that's a topic for another day, just on the ensemble. I think there's a couple of questions in the chat. Let me see. I think Andy was asking, when you do k-means clustering, will the result be different each time you run it?
That's actually a great question, Andy. And as I discussed that, usually, right, with any of the machine learning algorithm that you use, you would like to execute them multiple times to kind of take away any form of ranges that you have. So it won't vary a lot in terms of clusters being created, but you might have few records, a few data points moving across clusters here and there, because it's a very small partition that you have across clusters. Maybe this scenario was actually a great data set that you could have such clear demarcation, but more often than not, in more real life data sets, you will see that you have clusters which overlap over each other. And then when you run the k-means algorithm multiple times, you will see that few of the points which were in cluster A have moved to cluster B and cluster C and so on. So it's a good idea to kind of run those algorithms multiple times and kind of average it out to see what's the best possible representation.
Thanks, Anupav. We've got our upcoming events here for, sorry, do I have my thing on there? Using Pythons and MindsDB for machine learning with Snowflake. And then that's coming up in March. And then in April, we'll be talking about using Python to execute SnowPipe.
And we're trying to be the best Snowflake meetup that's out there across the globe. So if you guys know anyone who wants to join up or see any of our meetups or take part, definitely reach out and invite them. Of course, all the code that we put together here and all the sessions are out there. They're going to be open source while we record the sessions, put them on YouTube, the code we put out on GitHub. So everyone has access to that information and the cool work we're doing over here at AICG and DataLakeHouse. So definitely recommend us. And if you have a actual topic that you'd love to hear more about, or maybe something you're working on for either your organization, or maybe there's a client you're working on if you're in professional services or something like that, definitely send us a note. We just love this stuff. We love working with Snowflake. So just drop us a note either on Meetup or through another channel here. And we'll be happy to kind of dig into that topic and then, have a meetup on that subject.
Thanks, everyone. We hope to see you next month for our next one.